This is a lesson for Wednesday, November 11th. We're taking a look at domain range intervals and do a little sketching here. So what we're going to take a look at is some definitions first. To sketch a graph, we've talked about this already a little bit, but using minimal points, just roughly show the shape. We're doing that same thing. We're just sketching. We're not trying to get all the details. A sketch is fine. Key points, like for today, it's going to be vertex. For tomorrow, it's going to be relative mins and maxes. Just a few key points. Domain is the set of all possible x values. For quadratics, and really for all the polynomials, x to the third and x to the fourth, domain's always going to be all real numbers. Every number is possible. And we would denote that as negative infinity to positive infinity. When you write an interval like this, this says this is the lowest number or the lower boundary. This is the highest number or the upper boundary. The lowest x value you can get is negative infinity. The highest x value is positive infinity. So using this, what's called set notation, it says the lower bound, comma, the upper boundary. The lowest number, comma, the highest number tells you the range of numbers that are possible. Another way of saying that is just saying all real numbers. Every real number is possible. Not imaginary, but all real numbers. Range is all the possible y values. So because we're dealing with y values now, we're going to be talking about y. For a quadratic, if you, it's either going to be greater than or less than a particular number, and that number is the k value. So if I'm dealing with a parabola like this, you know h comma k, maybe this is like 7, negative 7. Everything bigger than negative 7. So it's going to go from that k value to infinity. Or if it's upside down, let me redraw that. So something like this. And let's say this is at negative 2. Then everything below negative 2 is what's possible. So from negative infinity up to that k value. Okay? Increasing interval, where the x values, what x values over which the y values are increasing. So where do the y values increase? What are the x values that show the y values going up? Decreasing, what are the x values that show the y values going down? Okay, so if you want to pause and get some of those definitions down. Sometimes people don't work well with definitions, and that's okay. That's why we're going to take a look at these examples here. So number one, we are going to start by just getting a sketch. The first thing I'm going to ask you to do is identify the vertex. Now we know how to find the vertex on the calculator, and I'm okay with you doing that. You could also, and again, this could be bonus, find the vertex by, didn't take my 4 out, using completing the square. And if you can find it by using completing the square, that's great. Minus 16 would balance it because it's 4 times 4. X plus 2 squared plus 8. The vertex is negative 2 comma 8. Great. Use completing the square to find it. I'll give you bonus if you do that, but you don't have to. Just use the calculator to find the vertex. Okay? So we're going to plot the vertex and sketch the graph. And I just showed you what the calculator showed. You're going to be actually sketching it. So I would go to negative 2 comma 8. I'll go by 2's here. Negative 2 comma 8, and it's facing upwards. Look at the a value. It's a positive 4. Because a is positive, we know it's facing upwards. And that 4 also means there's a stretch, so it's kind of a skinnier graph there. But just sketch it. That's all we're looking for. And really the only key point that matters is negative 2, 8, this vertex. These are the two numbers that matter. Really the 8 is the one that matters, that k value. Alright, so what we're going to do, we've sketched before. That's nothing new. But what we're going to do is we're going to find the domain range in increasing and decreasing intervals from that. So when I'm looking at, let me make this bigger. I think it helps to see the graph. Negative 2, 2, 4, 6, 8. Okay? When I'm looking at the domain is all the x values. For a quadratic, that is always infinity to infinity, negative infinity to positive infinity, or you can say all real numbers. I even let you abbreviate ARN if you want. because this graph will forever expand to the right and left. I know it's mostly going up, but it is getting wider. As that parabola goes up, it does get wider and wider and wider and wider. It goes forever left and right. Okay? But that's always, with all quadratics, the domain is always all real numbers. There is no x value that you can't plug in. Pick any x value in the world, and you're going to be able to plug it in to that equation up there. The 4x squared plus 16x plus 24. All x values are possible. Range, however, is capped. You cannot go below 8. There is no graph lower than a y value of 8. So what y values are possible? I could say everything greater than or equal to 8 and use an inequality, or I can state the range in set notation, the lower boundary and the upper boundary. The lowest number you can have is 8. Notice there's a bracket because it's equal to. The highest number it goes to is infinity because it goes up forever. And that's range. Now let's talk about the increasing interval. Over what interval are the x values increasing? So we read it like a book, left to right. So if I'm talking about the graph coming down to 8, here's my vertex. It's decreasing before 8, before negative 2. We're talking about x values. So it's decreasing until I reach an x value of negative 2. And then after negative 2, it starts increasing. So what is the increasing interval? It's everywhere that x is greater than negative 2. Everything past negative 2 on the x value is going to have the graph increasing at that area. Or I could say negative 2 comma infinity. From negative 2 to infinity. From this x value of negative 2 to infinity. From here onwards, it's always going to be going up. It's not like it ever turns back down or anything. It's going to be increasing or going up forever. How about a decreasing interval then? The decreasing interval, okay, so it decreases before it hits that vertex. So it's coming down. So we're talking about this right here. From negative infinity all the way till I hit negative 2. Excuse me. All the way till I hit negative 2. It's decreasing. So from an x value of negative infinity to negative 2, it will be going down or decreasing. Another way to state that, if you don't want to use set notation, you can use an inequality and say that when x is less than negative 2, anywhere less than or to the left of negative 2, that's where the graph is decreasing. It's going down. Okay? I do have another example. You could probably do the homework now from this point, but I do have a second example I'm going to go through quickly. This one's already in vertex form, so I already know the vertex without the calculator, and that's negative 3 comma 6, opposite of h and k. H comma k, negative 3 comma 6. So here's my vertex, and I do know that a is negative. Look at it, that's a negative in front. That's a reflection. That means it's been flipped upside down. So we have a sketch of a graph going upside down. The y value is 6. The x value is negative 3. Those are the two numbers we're going to be using. So again, domain, all real numbers. That's always the answer. Okay, I'm telling you the answer for the test. For a quadratic, x squared, domain is all real numbers or negative infinity to positive infinity. Okay? All right, so then let's go to range. The highest y value I get is 6, and the graph is everything lower than 6. So y is less than or equal to 6 would be the range. Or you could say it goes from negative infinity on the y-axis up to 6. From negative infinity is the lower boundary, up to 6. And notice the brackets, because it's including 6. 6 is part of the graph. It's this point right here, so it does include 6. Remember, brackets are the same thing as saying that something is equal to. And then I look at the increasing interval. It's increasing. Oh, well, now see, we flipped it upside down. It first increases until I reach negative 3. So from negative infinity to negative 3, or everything less than negative 3, before I reach negative 3 on the x-axis, it is increasing. And then after negative 3, it decreases or goes down. So after negative 3, from negative 3 to infinity, or when x is greater than or equal to negative 3. If you need help with this, pop back in. I'll explain it. I'll do a couple homework problems with you, whatever you need. Okay? Otherwise, get started on the homework.